In the previous lecture, we discussed the laws of indices. However, in this video, we are going to talk about some other properties that you need to consider when solving problems regarding indices. Now, let's start with the zero index. Now, this basically states that any non-zero number raised to the power 0 is equal to 1. So let's say we have 2 exponent 0, it is equal to 1. Let's say we have 100 exponent 0, that is equal to 1. If you have x exponent 0, is equal to 1. And then if you have a exponent 0, it is equal to 1. The next on the list is the negative index, the rule that talks about the negative index. Now, if you have a exponent negative n, then you can represent that as 1 over a exponent n. So for example, if you have 2 exponents negative 1, then it's equal to 1 over 2 exponent 1, which is equal to 1 over 2. If you have 3 exponent negative 2, it is equal to 1 over 3 exponent 2, which is equal to 1 over 9. Because 3 exponent 2 is 3 times 3, which is equal to 9. How about if you have a fraction with an exponent? Let's say you have a over b exponent n. Now you need to distribute this n across. So it's going to be a exponent n divided by b exponent n. Now let's take an example. Let's say you have 2 over 3 exponent 2. Then it means that we are going to have 2 exponent 2 divided by 3 exponent 2. Now 2 exponent 2 is 2 times 2, which is equal to 4. And 3 exponent 2 is 3 times 3, which is also equal to 9. So 2 over 3 or exponent 2 is equal to 4 over 9. Now let's talk about the negative index of quotient. Now if you have a over b exponent negative n, then you can interchange a and b and write it as b over a exponent n. From there, we can represent it as b exponent n over a exponent n. So let's say we have 3 over 5 exponent negative 2. Then we can interchange the 3 and then the 5 to have 5 over 3 exponent 2. Then we distribute the 2, and then we have 5 exponent 2 over 3 exponent 2. Now 5 exponent 2 is 25, and 3 exponent 2 is 9. So we have 25 over 9 as the final answer. Now let's talk about fractional index. Let's say you have a exponent 1 over 2. It is the same as having the square root of a. So if you have 25 exponent 1 over 2, then you can express it as square root of 25. And then the square root of 25 is 5, because 5 times 5 is equal to 25. Let's say you have 9 exponent 1 over 2. That is equal to square root of 9. And then we have 3. And if you have a exponent 1 over 3, then it's equal to the cube root of a. And if you have a exponent 1 over 4, it's equal to the 4th root of a. So for example, let's say you have the cube root of 8. Now, we can represent this as 8 exponent 1 over 3. We know that 2 cube is equal to 8. So times exponent 1 over 3. Now 3 cancels 3, and then you have 2 exponent 1, which is equal to 2. And again, if you have the 4th root of 16, then you can represent that as 16 exponent 1 over 4. Now 16 is equal to 2 exponent 4. So we have 2 exponent 4 times 1 over 4. Now 4 cancels 4, and then you have 2 exponent 1, which is equal to 2.